Here we're going to solve some polynomial equations using the factor theorem. So again, the steps to solving polynomial equations is to set the equation to 0, factor, and then find the solutions from that. The first equation here that we have is already set to 0, so we don't need to worry about that part. The first thing we got to do is factor it. So to factor it using the factor theorem, we need to find one of our zeros first, right? So what are the possible zeros? And the possible zeros are basically follow this pattern, P over Q, where P is the factors of the constant, Q is the factors of the leading coefficient. So in this case, we have P as our constant is 10, right? We don't worry about the negative there. So 10 is P, and our Q is our leading coefficient, which is 6. So our possible factors, or our possible zeros, are any value that's a combination of the factors of these. So the possible factors, let's do this. Possible factors, or possible zeros, I should say, are any factors of 10, which are 1, 2, 5, and 10, over any possible factors of 6, which are plus minus 1, 2, 3, and 6. But it can also be any combination of these. So again, I'm going to list out all the possible zeros that we have in this case. So I'm going to start off with this. I'm going to basically work and do 1 over 1, then 1 over 2, then 1 over 3, then 1 over 6, then 2 over 1, 2 over 2, 2 over 3, 2 over 6. Just so you sort of know the pattern that I'm doing that in. So the possible zeros are, plus or minus 1 over 1, which is just 1, 1 over 2, 1 over 3, and 1 over 6. Then I'll start with the 2 on top. 2 over 1, which is just 2. 2 over 2, which is just 1, which we already have. 2 over 3, which we don't have yet. And 2 over 6, which reduces to 1 over 3, which we already have, so we don't need to include it again. Then we have 5 over 1, which is just 5. 5 over 2, which we don't have yet. 5 over 3, again, we don't have that. And then 5 over 6, which we don't have. I'm going to continue this on the next line. 5 over 3. Then we work with the 10. 10 divided by 1, or 10 over 1, which is just 10. 10 over 2, which is just 5, which we already have. 10 over 3. And then 10 over 6, which reduces to 5 over 3, which we already have. So these are all the possible zeros for this equation. Or in other words, the possible solutions to this equation. All of the possible zeros here, all of the zeros, all of the answers to this solutions to this equation are going to be in here. So we know this is a 4th degree polynomial, so it could have up to 4 roots or 4 zeros. So up to 4 of these can be there. Now, you don't want to just sit there plugging in all the values, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there's the plus and the minus version of each of those. So that's 24 different numbers. You don't want to just sit there plugging in 24 different numbers, right? If we could find one of the possible roots. So by starting to plug in the first few, we can find one of the possible roots and then factor the rest to find the other 3. All right, so that's what we're actually going to do when we solve a question like this. So we can start working through and guessing which ones work. Now, this is a lot of combinations. If I asked you to do a question like this on a test or quiz, I wouldn't expect to give you one that has this many possible factors, because that could take forever to find the correct one. And for this, if you want to try it yourself, you can pause the video here and try it yourself. But I'm going to give you the first one. So the first one you could find that you may come across if you start plugging them in is f at negative 2/3 is equal to 0. So that is a possible zero, negative 2/3. Well, it is a 0 because it comes out to 0 if you plug it into the equation. So if we know that that's one of the zeros to the equation, or one of the solutions, then we know that x plus 2/3 is a factor, right? Now, one other thing is that we don't usually have fractions in our factors. We can actually get rid of fractions by, you can sort of look at it as getting rid of the fraction by multiplying both terms by 3. So we could actually use this 3x plus 2 as a factor. right? Because if you think about it, if this was a factor, you can move the 2 to the other side to become -2, divide by 3, and you'd still get this 0 of -2/3. So it's up to you which one you want to use. Yeah, either one should get you the right factored answer at the end, though they might look a little bit different. And also, one other thing is that if you're using synthetic division, you could use either of them as well. Just remember, if we're using this one, you have to do that dividing by 3 thing at the end. So I'm actually going to use a little bit of long division here, just because, why not? And I'm going to use this one because I think it's a little bit easier. You don't have to work with the fractions when you're doing the long division. So 3x plus 2, that goes into 6x to the 4 minus 17x cubed plus 7x squared minus x minus 10. Bit of a process. Okay, so let's do some long division. This is going to be 6x to the power of 4. That's going to be 2x to the power of 3. That goes in there. So then 2x to the power of 3 times that will give us 6x to the 4 plus 4x to the 3. Then I'm going to subtract negative 21x to the 3, bring down that 7, plus 7x squared. So to get that to be negative 21x squared, I'm going to multiply by negative 7x squared, right? Negative 7x squared is going to give us negative 21x cubed, multiplied by the 2, which is negative 14x squared. Subtract. So 7 plus 14 is 21, right? Because we're subtracting a negative. Be careful with that. 21x squared minus x. So then I'm going to multiply that. 3x times 7x will give me 21x squared, right? So that's 21x squared, and then plus 14x. Subtract that. Negative 1 minus 14 is negative 15x, and then bring down that 10. And then let's do that one more time. So it's going to be negative 5 that I need to multiply that by to get that. So it's negative 15x minus 10. Good. It checks out that it's a factor. Remember, it should come out to 0. The remainder should come out to 0 if it was correctly a factor. So that's what I get. The simplified version is that. So I factored it. So therefore, it's equal to 3x plus 2, and then 2x cubed minus 7x squared plus 7x minus 5. There we go. So that's our new factored form. So we've taken it down from a cubic to a linear factor and a cubic factor. Or sorry, we've taken it from a quartic, 4th degree, to a linear and a cubic factor. So now we go again. Can we factor this part, right? And that's what our next step is, to factor that. Now, again, it's a cubic, so we have to use factor theorem again. So it's a bit of a pain, but the number of factors are going to be a little bit less this time because we already factored out, like we factored out part of this 10 and part of this 6 from the original one. Now we have a 2 and a 5. So we've made it a little bit simpler for ourselves. The factors that are going to go in there are going to be a little bit easier, but still, we still a bit of a pain that we got to find it. But let's you know what, we're going to do this one rigorously. Let's find the possible zeros again. So it's going to be any multiple of 5, right? So it's going to be 1 and 5, right? Because we're looking for the factors of this part over the factors of this part, right? And the factors of 2 are going to be 1 and 2, right? So our possible zeros is a lot shorter of a list than last time, right? Oops. It's going to be 1 over 2, or 1 over 1, so 1 plus minus 1, 1 over 2, 5 over 1, which is 5, or 5 over 2. So there's only 4 possible zeros, or actually 8 possible zeros, because you have to do the positive and the negative version of it, right? But when you do that, so I'm just going to give you the spoiler here again. If you want to try it yourself, you can pause it. But the thing that gives you 0 is 5 over 2. So the factor that corresponds to that is either x minus 5 over 2. Or again, if we do the same trick as last time, or is a factor, or we could do the same trick as last time, so basically get rid of the fraction, multiply it by 2, so 2x minus 5 is a factor. Okay? So because we know that that's a factor, we can do the division again, right? So let's do the division. I'm going to do the same thing I did as last time. I'm going to divide by this. But just to change it up, I'm going to use synthetic division this time because I want it to be, I want to show you sort of both ways to do it. So the number that we're going to divide by is going to be 5, right? And then we have to do our manually dividing by 2 thing at the end, right? Just I put that note there so that we remember to do that. But the polynomial we are trying to do this with is this one here, right? So 2, negative 7, 7, negative 5, right? Okay, so let's do this. Bring down the 2, and then divide by 2. Remember, you can't forget to do that when the leading coefficient is not 1. So we get 1. 5 times 1 is 5. Negative 7 plus 5 is negative 2. Divide by 2, which is negative 1. 5 times negative 1 is negative 5. 7 plus negative 5 is 2. And then divide by 2, which is 1. 5 times 1 is 5. Negative 5 plus 5 is 0, exactly as we'd expect. Okay? So the factored out version here, remember, we started off with this, right? We started off with this up here. And what we get after the division is that this is an x squared minus x plus 1, right? That's what this synthetic division means at the end, right? When we divided it by, what was it, 2x minus 5. So at the end, our final factored form, or our next step in our factored form, is we still have that 3x plus 2, right? Because that was the first part, but then we factored this. So the factor that came out was, well, the one that we found was 2x minus 5, right? But then after the division, we got x squared minus x plus 1. Okay, so now we've successfully taken it down from a 4th degree polynomial down to two linear polynomials and a quadratic. So once you have a quadratic, you don't need to use the factor theorem anymore. I mean, you technically could use factor theorem again, but we have other tools for factoring a quadratic, which you learned in grade 10, right? So, for example, sum and product and stuff like that. So we should ask ourselves, can we further factor this? So using product and sum, we need two numbers that multiply to give us 1 and add to give us negative 1. Is that possible? No, right? There's no two numbers that multiply to give us 1 and add to give us negative 1. So what this is basically telling us is that this, let me do that in a different color, that this part here is not factorable. But because it's not factorable, it doesn't mean it doesn't have any solutions, right? It just means you can't factor it. It still could have irrational solutions. And the way we find irrational solutions is by using the quadratic formula. So, therefore, quad formula. So let's just see if we can find more solutions to this using that. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can plug in our values. Our b is negative 1. Our c is 1. Now if you look at this right away, you should sort of see that the discriminant, the thing under the square root, is going to end up being negative 1 squared minus 4 times 1 times 1. So it's going to be negative, right? Because it's going to be negative 3, right? So because this is negative 3, it means there are no solutions. Okay, from that quadratic. So it basically means this part right here, it not only is it not factorable, but it has no solutions. So no solutions are going to come from that. So the only solutions to this quartic function are going to come from here and here, right? So it's going to be x equals negative 2/3 and x equals 5 over 2. Because there's not going to be any solutions coming from here because of the quadratic formula. All right, So there we go. That's the solution to this equation, right? It's a lot of work to find one solution. Again, it's a little bit easier if you use synthetic. Like here, it took a lot of work to do the long division. But if you're more comfortable with long division, it's absolutely fine. But just know, like that's the process to find it. You got to do factor theorem as many times as it takes to get it down to a quadratic. And then once it's a quadratic, you can use the quadratic formula or factor. Okay? So this quartic function has 2 zeros. Even though a quartic function could have up to 4 zeros, this one only has 2. And if you graph it on Desmos or whatever, you can see that there's only two zeros, 2 places it crosses the x-axis. All right? So that's the general process. That's a more involved question. Most of them aren't going to be quite as long, just because this one required us to use factor theorem twice and then the quadratic formula. But as long as you're keeping track of the factors, the things you're factoring out as you go, and you're making sure that your remainders come out to 0 on your division, you should be okay. There we go.